Hello everyone, welcome to Ansarkari, and this video is the video for concept number 10 in the continuation of the permutation and combination series. Now the statement says the number of ways of arranging n persons at a round table that is in a circle is equal to n minus 1 factorial. So till now we were dealing with the linear arrangements. Linear means that involve the patterns of arranging in a line. Right, but now we'll discuss that how is it possible in a circular fashion. So to understand the formula, okay, so in the linear case, in the general case, the formula is n factorial, right? If this case of arranging n persons at a round table, the formula is n factorial. If round table is not to be considered, just a q is to be considered, right? So the formula is n factorial, but here what happens is n minus 1. We subtract 1 from n and then we put the factorial. So what is the reason for this? Let us try to understand that. Suppose I draw a circular table here and 5 people are meant to be seated here. Now what happens is, suppose we have 5 people, that is A, B, C, D and E. So these are the 5 people that we have. A can be seated at any of the 5 places. A can be seated here or here. If we start with A, we can start with any person. That doesn't matter. What matters is that the first person, any of them, that the first person that we choose, who is supposed to sit at any of these, will have all the options, but these options will not be of difference to this person. चाहे वो इनमें से किसी भी सीट पे बैठे उसके लिए कोई फर्क नहीं पड़ेगा बिकॉज द व्यू विल बी द सेम. सर्कुलर में और लीनियर में यही डिफरेंस है. लेकिन वही अगर हम क्यू की बात करें या फिर डिफ्रेंशिएट करने का ट्राई करें तो अगर इनमें से हम कोई भी पहले इंसान ऐसा चूज करता है who is supposed to be seated or perhaps who is supposed to stand in this queue. If the person A stands at the third position, then the matter will be different. If the person A stands at this position, then the matter will be completely different. Or any of these. I am taking right now the example of the person A. Any of them can be chosen. That doesn't matter. What matters is the options available for the first person. They will be completely equal in the, they won't matter, they won't be different in the circular case, but in the linear case they will be different. That is the reason why we put the formula n factorial in case of the linear arrangements. But in circular, what happens is that the first person, now n is this, right? So any of these, so we subtract that one first person whatever we choose, because everything will be the same for that first person. That is why we subtract and then we write n minus 1 factorial. तो जो बाकी के जितने बचेंगे, फॉर एग्जाम्पल वी चोज सी. अब सी के लिए एवरीथिंग वाज जस्ट द सेम, बट फॉर ए बी डी एंड ई things will matter. The queue or the arrangement will matter in circular case. Linear case में हर एक के लिए मैटर करता है, बट इन सर्कुलर केस द फर्स्ट पर्सन, फॉर द फर्स्ट पर्सन इट डजंट मैटर, बाकी के लिए इट विल मैटर. बिकॉज सपोज अगर हमने ओके वी जस्ट टुक नाउ सी, सो अगर हमने सी को इस सीट पे बिठा दिया तो बाकी के जो ए बी डी और ई हैं, अगर ये यहाँ बैठेगा तो फर्क पड़ेगा बिकॉज ए इज एट द राइट साइड ऑफ सी. अगर ये यहाँ बैठेगा इवन देन इट विल मैटर बिकॉज ए इज टू द सेकेंड लेफ्ट पोजिशन ऑफ सी, राइट? सो इट विल मैटर बिकॉज यहाँ पे हमने एक रेफरेंस पॉइंट क्रिएट कर दिया. तो इस रेफरेंस पॉइंट को अगर हम देखकर चलेंगे देन द अरेंजमेंट्स विल मैटर. जहाँ पर भी हम उठा रहे हैं वो मैटर करेगा. बट सिंस इन द बिगिनिंग देयर इज नो रेफरेंस पॉइंट, जो कि क्यू में तो हमेशा होता ही है बट सर्कुलर में नहीं होता. दैट इज द रीजन व्हाई वी सब्ट्रैक्ट 1. नाउ अनदर एग्जांपल वी कैन टेक इज सपोज वी अरेंज लाइक ए सी बी डी ई. अगर हमने इसको इस तरीके से अरेंज करा इन द सर्कुलर थिंग इटसेल्फ, तो सर्कुलर थिंग में वी कैन स्टार्ट विद सी एंड एंड एट ए. फिर हम बी से स्टार्ट कर सकते हैं. दैट इज स्टार्टिंग विद सी मीन्स अगर हम इसको ऐसे देखें, राइट, तो इट विल बी completely the same thing. क्यू में दिस थिंग विल मैटर, दैट इज इन द लीनियर अरेंजमेंट, बट सर्कुलर केस में वो मैटर नहीं करेगा. तो यानी कि अगर 5 लोग हैं, इफ वी टेक द एग्जांपल दैट वी हैव 5 people, in that case what happens is 5 factorial, this will be the linear arrangement, but हमें 5 से इसको डिवाइड करना पड़ेगा. दिस इज अनदर वे ऑफ अंडरस्टैंडिंग द सेम थिंग. because there will be 5 cases जो हम अलग अलग मान सकते हैं Q में, but in the circular fashions they will remain the same. So this should be 4 factorial. And in general now we had like n people, so 5 is equal to n. Then automatically the answer comes. Generally in linear case what happens is 5 factorial, but in case of circular fashion it will be n minus 1, which is 5 minus 1 4, and then factorial. This is the reason why we have this formula. Now taking up the 16th question, in how many ways can 6 persons be seated in a line? And second part is at a round table. Now in a line ka jo सीधा formula, that is n factorial, and n here is equal to 6. So it will be 6 factorial, which is 720. This will be our answer for the first part. For the second part, we need a circular arrangement. Round table means circular arrangement. In that the formula is n minus 1 factorial. The reason we have discussed in the previous slide. So it will be 6 minus 1 factorial, which is 5 factorial, which will be 120. So the answer for arrangement in round table will reduce and it will be 120. Now in the 17th question, what they say is, in how many ways can 5 ladies and 5 gentlemen be seated at a round table so that no 2 ladies are seated together? So here the condition is that no 2 ladies are supposed to sit together. Now this question can be a bit peculiar if we read it for the first time, but it is simple. What we'll do is we'll simplify the cases. Now for example, the only condition is that no 2 ladies are supposed to sit together. So what it means is that there should be at least one man, one gentleman that is supposed to sit between any 2 ladies, right? So first we'll arrange the 5 gentlemen and then we'll see how to arrange the 5 ladies. Now when we arrange the 5 gentlemen, we'll just draw these 5 marks or whatever. So these represent the 5 gentlemen. Now the general formula says n factorial, right, for the linear arrangement. But in circular case, it is n minus 1. N here is equal to 5. We have 5 gentlemen. Right now we are focusing on just the gentleman case. So the formula will be n minus 1 factorial, which means 5 minus 1, that is 4. Then 4 factorial, which will be 24. So this will be the number of ways, the number of arrangements in which we can arrange the 5 gentlemen. That's all. Now when we come to ladies, the ladies are supposed to be seated in these many places. The cross marks that I have made represent the seats where the ladies can be seated. And they cannot be seated at any other place. Now here in this case what happens is, we do not have to subtract 1. The reason being, here we have reference points. For example, a person or like 5 gentlemen have been seated here. Even if 1 gentleman was to sit here, even then the reference point is marked. So जो पूरा arrangement है, that will matter as in case it happens in the Q case. तो इस केस में जब हम लेडीज को अरेंज करेंगे, we do not have to subtract 1, because if we like suppose this lady sits here, it will matter if the lady sits here or here, because if the lady sits here, then this lady will, suppose this is the first man, so or the one person, so suppose this lady sits here, so she will be on the left side of this first person. But if the same lady sits here, she will be on the right side of the person, so the arrangement will matter. Easily we won't subtract 1 in this case and we'll directly take n as 5 and it will be 5 factorial itself. तो we need to understand the concept कि हम क्यों subtract कर रहे हैं 1. जैसे ही हमने किसी को भी सर्कुलर अरेंजमेंट में बिठा दिया इन सिंपल वर्ड्स ऐसे, उसके बाद ही n-1 वाली चीज़ लगनी बंद हो जाती है. इट हैपन्स ओनली इन दोज केसेस जब हम फर्स्ट किसी को बिठा रहे हैं फिर अरेंज करना स्टार्ट कर रहे हैं. Now the answer will be 120 for 5 factorial. Then 120 into 24, if we solve, we have like 2880 as our answer. Now the 18th question says that the 11 cabinet ministers of a state sit together to discuss a report. In how many ways can they seat themselves at a round table so that the education and revenue ministers sit together? So isme total, okay, so this question is kind of similar to that question in which we say that the vowels should occur together or perhaps these many letters should occur together. Together means साथ में, right? We have discussed these kind of questions. In this case, the difference is just this, that यहाँ पे circular case आ गया. So originally the total number of elements that you have is 11, or perhaps elements here means the cabinet ministers of a state who are supposed to sit together. But here what happens is, two elements, that is education minister and revenue minister, they are supposed to sit together. Why to 11? We have that formula, right? N minus P plus 1. Because we consider this as one element itself, the whole, like education and revenue ministers, they will be considered as just one element. We have discussed these kind of questions earlier also. So P is like the number of elements that should occur together, then plus 1. So if we do this, the answer will be 10, right? If we use this formula itself here. So now we have total number of 10 elements that we need to arrange. Now normally if we see the number of ways of arranging these in a circular fashion will be like n minus. Okay, so the new n is this. N is not this now. The new n is equal to 10. Now what happens is, the formula, the circular formula, if we apply, the answer should come by this. So we'll write here 10 minus 1 and then factorial, which will be 9 factorial. So we can solve it. But the next thing that comes here is the education and revenue ministers. Now the difference can be that now education and revenue minister have to sit together. Okay, that we have discussed. But within this element that we have taken to be one, this particular element, revenue minister, suppose this is revenue and this is the education minister. Education minister can be on this side and revenue on this side. So same can be the case in this thing. It was just to explain. So we'll multiply this with 2 factorial, because the ways of arranging within this particular element, that is the ways of arranging the education and the revenue ministers, they will be 2 factorial. And the normally total number of ways of arranging will be 9 factorial. So answer will come by this thing, which will again be equal to 725,760. Thank you everyone.